Hello everyone. Today my topic is community detection in online social networks. To start my presentation, first I will show you the most famous GN algorithm and FN algorithm in the field of community detection. And then I will compare these two algorithms, mostly focus on the complexity. And then I will go to test these two algorithms using the real-world network. Okay, before I start it, you may want to ask me a question. What is community detection? That idea is first provided by Newman and Jervin in 2004. They say a community is a subgraph containing nodes which are more densely linked to each other than to the rest of the graph. This idea is not hard to understand. For example, there are 8 children in our neighborhood. Maybe these 4 guys prefer to play with each other, so we may say they belong to community A. And these 4 guys prefer to stay with each other, so we may say they belong to community B. People in these two communities can interact with each other, but not too much. For example, this guy in community A may know this guy in community B, but they don't play with each other too much. Okay, another question is how to evaluate the quality of our community. And most often, we use the modularity to evaluate the quality of our detection result. And here is a mathematical function. We use the function of internal ages minus the expectation, so we get the modularity. Now let's go to the Jervin-Newman algorithm, and I will give you the idea of that algorithm. First, we assume all the nodes belong to one community, and we find the age with smallest age betweenness. We just delete it. So sometimes we may find that we form a new community. Then we compute the modularity under such situation and record that node structure. We will repeat these procedures until all the ages are deleted and find the node structure with highest modularity. For the modularity, the higher the better. Here is the algorithm for age betweenness. You can see from here, it is really time-consuming and it is really complex. Because of the high complexity in GN algorithm, another algorithm called Faust-Newman algorithm has been raised. As beginning, each node is a sole community, so we join the communities together in pairs and select the join with highest increase or smallest decrease in modularity. You may see this algorithm avoids computing the age betweenness, which decreases the complexity greatly. Now let's go to the feature of GN algorithm. First, let's focus on the complexity. It is really high. Assume a network with m ages and n nodes. The complexity of finding the betweenness of any age is O(n), because we have to traverse all the remaining ages to find the one with highest betweenness. The complexity can rise to O(m)n). Further, there are totally m ages needed to be removed during the whole process. So the overall complexity of the GN algorithm is pretty high. It's O(m²n). But we gain the high accuracy. which is nearly 100%. For Fn algorithm, the complexity is decreased to O(Mn plus n squared). That is much better than what we obtained from Gn algorithm. However, at the price of low complexity, the accuracy of Fn algorithm is slightly injured. But still, it is acceptable. I will show you next in our test. Now we will use a famous real-world network called Karate Club Network to test the efficiency of both Gn and Fn algorithm. Here is some background knowledge of Karate Club Network. Those club members are split into two groups because of a dispute. And here is the ground truth of the grouping result. We may use this graph to check the correctness of Gn and Fn algorithm. Okay, let's start it. First, we will open this project. It is the Gn algorithm. First, build solution, one object date. Debug, start without debugging. It starts detecting communities, but this will take some time. Really time consuming. You may see from here, the total running time is 12.251 seconds. And the nodes are grouped into two communities. Here 1, here 2. And if you check from the ground truth, you may find it is in complete agreement with our ground truth. And running that algorithm, we will get a txt format file here called output h. It is a txt format file, and we just use this file to draw our node structure. It is another graph. And first we need to put all this data into an Excel format file. I have done that in advance. I use this software. I use this software to draw the node structure. The software is developed by University of California, Irvine, and we just started. Data, input, Excel metric, and we type in the path of that Excel file. You may see from here it is output h. Open. Click OK. OK. We will get a ++h format output log file here. And we just use this file for the net draw. Yes, visible net draw. Another application pop-up. Click File, Open UCI Dataset, Network, and we type in the path again. It is this one, .++h, open. Okay. And here, we just get the community structure we detected from the running program. Okay. And let's try another one with the Fn algorithm using the same input data. Here, we just click Run. It is so quick. So you can see we again get the detecting result. Using FN algorithm, we get two communities. It is from node 6 to node 14, and another community from node 9 to node 23. If you check from the ground truth, you may see that only this node, node 3, is wrongly grouped. But that result is really acceptable. And you may see from here, here is the running time. It is only 0.28 seconds, less than 1 second. It is really quick when compared to the GN algorithm.